Today we're going to talk about the area of shapes, and some of these shapes you've seen before. A couple of them are new, so we'll focus our attention on the things that are new. So here are the formulas that you have access to. A rhombus, it says 1/2 diagonal 1 times diagonal 2. So the diagonal is a line that goes from corner to corner of the non-adjacent sides. And something you need to know about a rhombus is those diagonals make a right angle. So we're going to be able to use the Pythagorean theorem to find missing pieces. The kite has the same formula. It's a little bit of a different shape than the rhombus, but it has the same formula, diagonal 1 times diagonal 2. And you've discovered a couple of things about a kite, that the diagonals are perpendicular, and this short diagonal was bisected. It was cut in half. So that's going to come in handy there. A regular polygon, that's a new one. Any shape bigger than 4 sides, we're going to refer to as a polygon, a pentagon, a hexagon, a heptagon, octagon, any of those. This happens to be a regular octagon. A regular polygon has congruent sides. They're all the same length, and it has congruent angles. They're all the same measure. So that's a new one that we're going to talk about. It is 1/2 PA. P is the perimeter of the shape, so you add up all the outsides, which they're congruent sides, so all the sides are the same. The apothem is this segment that's from the center perpendicular to the side. And it also cuts that side in half. I don't know if you need to know that, but it's there. But the apothem is going to be from the center straight down, and we usually are going to give that to you. So let's get started. The area of a square is 100 square meters. Find the length of the diagonal of the square. Well, we know if a square is 100, that the sides must have been 10 times 10 to get an area of 100. So the question here is, what's the length of the diagonal? So the diagonal is this line that goes from corner to corner. And because it's a square, I think I'm going to use the Pythagorean theorem. So we're going to say 10 squared plus 10 squared equals x squared, because that's the diagonal. So this is 100 plus 100. So 200 equals x squared. And when I take the square root of both sides, here's something. We're not just going to hit the calculator and get a decimal. We are going to simplify the square root of 200. So we're going to break down the 200, maybe 2 times 100. And then 100 breaks down into 10 times 10. And when I simplify radicals, I like the buddy system. If you have a buddy, you get to go out of the house. If you don't have a buddy, mom won't let you leave. So in this case, x equals 10 root 2. So we're going to want the exact answer unless we tell you to round it off to a particular decimal place. This is the exact answer. The square root of 200 simplified. The next one, find the area of an equilateral triangle with a side length of 12. So equilateral means that all of the sides are equal. They're all 12s. So the formula for area is 1/2 base times height. Well, I know the base of my triangle is 12. I don't know how big the height is. So I'm going to calculate that. The way we calculate that is going to be the Pythagorean theorem. This altitude or height that comes down cuts the base in half. So I have a right triangle with a leg of 6 and a hypotenuse of 12. So I'm going to use the Pythagorean theorem to find my height, this missing piece. So I will do a squared plus 6 squared equals 12 squared. So I get a squared plus 36 is 144. And when I subtract 36 from 144, I get 108. So I get a squared is 108. So just like the previous question, when I take the square root of both sides, I'm not going to do the decimal. I'm going to simplify the square root of 108. So you can use your calculator to help you figure out what goes into 108, but I think I remember that it's 9 times 12. 9 is 3 times 3. There's some buddies. 12 is 4 times 3, and I know 4 continues to break down into 2 times 2. So to simplify 108, 2 times 3 is 6. This 3 didn't have a buddy, so Mom made him stay in the house. That is my height, my altitude. So I'm going to multiply 1/2 base 12 times height 6 root 3. And for my final answer, I'm just going to multiply the 1/2 times 12 times 6. And that's 36 times the square root of 3. And that's exactly how we leave it. Square inches. I'm not taking off for units, but I'll put them on here when we practice. So notice we multiplied the numbers in front, but we didn't multiply the radical because there was no other radicals to multiply it with. All right, next up, find the area of the trapezoid. Notice the directions say to the nearest thousandth, so we're going to leave decimals on this one. The area of a trapezoid is 1/2 height, base 1 plus base 2. So the trapezoid, the height is perpendicular to the base, that's this 10.462, and the bases are the 8 and the 11. So we're just going to plug our numbers in. This one should be pretty simple. 10.462 times 8 plus 11. Please show this part of your work so we can see what numbers you plugged into your calculator. We don't know what you did in your calculator unless you tell us. So now I'm going to plug this in. Let's see. 0.5 times 10.462 times 8 plus 11. So it's 99.389 square centimeters is the area of my trapezoid. All right, next up is our first regular polygon. It says find the area of the regular pentagon. Penta means 5, so notice it's a 5-sided figure. So our formula for a regular polygon is 1/2 perimeter times apothem, or apothem. So since all of the sides are 14, I can just do 14 times 5 for my perimeter, which is 70. My apothem here is 4.549, and I plug that into my calculator. 0.5 times 70 times 4.549. And my answer is 159.215. It's the thousandths place, that's 3 decimal places, and that's exactly what we did. So any polygon, a pentagon, hexagon, octagon, any regular polygon, here's your formula, 1/2 perimeter times the area, or apothem. All right, next up, a rhombus. So the formula for a rhombus, area equals 1/2 diagonal times diagonal. So let's start out with this diagonal. I've got a 12 right here. Now in a rhombus, the diagonals bisect each other. So this 12 means that this is also 12. So my first diagonal is 24 from end to end. Now I'm going to need to calculate this other diagonal because I don't have any measurements there. So look what I'm going to do. I'm going to take this part right here. Now we've been told you that the diagonals are perpendicular. That's a right angle. So I have a right triangle with a missing leg. So if I go a squared plus 12 squared equals 13 squared, you can put that into your calculator and you're going to find out that that missing leg is 5. So in your calculator, you're going to go the square root of 13 squared minus 12 squared because we were missing a leg. If you know the hypotenuse, you're going to subtract those. And that turned out to be 5. So the length of this entire green diagonal is 10. Half of 24 times 10 is 120 square centimeters. So that's for a rhombus. Every rhombus, the diagonals are perpendicular, so they make right triangles. Next up is our kite. Find the area of this kite. The kite formula is identical to the rhombus formula, but the kite's a slightly different shape. So we have the diagonal that goes across here. And if you remember, these two pieces are the same. Those little hash marks mean they're congruent. And then we have the diagonal that goes from top to bottom. Those are not the same, the top piece and the bottom piece. So we're going to have to do some calculating. So if I start out, I'm going to look at this bottom triangle right here. The diagonals are perpendicular, just like we said for a rhombus. So I have a right triangle. I know the hypotenuse and one of the legs. So let's find that other missing leg. So if I said x squared plus 35 squared equals 37 squared, I can solve that with my calculator to find out what that missing piece is. 37 squared minus 35 squared. Yep, it's 12. So Pythagorean theorem told me that this part right here is 12. And since the other piece of the diagonal is congruent to it, that's also 12. So I've got one of my diagonals is 24. We're off to a good start. The other diagonal, the yellow one, I've got 35 from here to here, but I need this top piece. So I'm going to do the Pythagorean theorem again. This time up here with the 12 and the 13. Now you might remember we just did that. We just did a problem that said x squared plus 12 squared equals 13 squared. And we found out that x was 5. We did that in the previous question. So if this piece right here is 5, then the entire diagonal is 40. And that's what I'm going to put in my calculator. 1/2 times 24 times 40 is 480. So my answer for the kite is 480 square centimeters. Little Pythagorean theorem to help us find the missing pieces. But remember that that center is a right angle, so that's why we're allowed to do that. All right, the last example we're going to look at has to do with what we call dimension changes. So I'm going to take a square and I'm going to change the dimensions. Notice the first square is 5, the next one's 10, so I did times 2. And then from 5 to 15, I did times 3. So we're going to see what happens to these different squares when I find the areas and the perimeters and how they compare to each other. First of all, it says write the ratio for the side lengths. Well, the side lengths were 5, 10, and 15. If I reduce those by dividing everything by 5, I get 1, 2, 3. So we did times 2 times 3. Now let's answer the next one, the perimeters of the squares. Well, the perimeter of the first one, 5 times 4, 10 times 4 for the square B, and the perimeter for square C, 15 times 4 is 60. Well, let's compare the perimeters. 20, 40, 60. If I reduce those by dividing by 20, I get 1, 2, 3. So notice that the perimeters have the same ratio as the side lengths. It's still 1, 2, 3. Now let's calculate the area of each square. The area of this square is 5 times 5, This one is 10 times 10. And this one is 15 times 15. So now they've asked us to write a ratio for the areas. I have 25, 100, and then 225. If I simplify that by dividing everything by 25, I get 1, 4, 9. So notice the relationship. Area, remember, was in units squared, square units. And notice all of these ratios are squared, 1 squared, 2 squared, 3 squared. It's an interesting relationship. Okay, so do some practice and work on your check.